Titration is a composite of many techniques. It is one of the most accurate procedures you will meet in your chemistry lab work. We begin the process by using deionized water to dissolve a solid acid sample. This titration calls for adding about 50 milliliters. The "about" means we can pour in the deionized water and use the graduations on the side of the flask to tell when we have reached about 50 milliliters. Adding the endpoint indicator is the next step, 2 drops to each flask. Your directions may call for a different number of drops. Just be consistent in all of your samples. This particular solid sample is difficult to dissolve. It requires extensive swirling. All solid granules must be dissolved before the titration can begin. A deionized water rinse is critical to ensure that all solid granules have been removed from the flask walls and dissolved in the solution. It takes a thorough 3 times around rinse to ensure that all of the solid acid has been rinsed into the solution. We prepare our burette for use by checking to see that the stopcock is closed, filling the burette with deionized water, and then checking for quantitative drainage. We need to examine the burette to be sure its walls drain cleanly, both to prevent contamination and to be sure that titrant volumes are accurately read. Place a waste beaker beneath the burette tip and open the stopcock to allow the deionized water to empty from the burette. This burette is droplet-free. It is quantitatively clean. If droplets do show up on your burette, further cleaning will be required. Now we are ready to rinse the burette with our titrant, sodium hydroxide. Note that a funnel is used to prevent spilling the titrant. To conserve titrant, we rinse with small portions. We perform a titrant rinse 3 times to remove any deionized water left in the burette. Thoroughly rinse the internal burette walls by holding the burette on its side and rolling it. Rinse the burette tip by holding the burette over a waste container or sink and allowing all the liquid to pass through the tip. Remove the last drop and continue to do a second and third rinse. Then fill the well-rinsed burette with titrant. Take care to lift the funnel for smooth delivery. Watch carefully to avoid overfilling the burette. We cap the sodium hydroxide bottle to keep the acidic carbon dioxide in the air from reacting with the base in it and changing its concentration. Run some titrant through the tip into the waste container. Check carefully for any bubbles in the tip, which, if not removed, will cause volume inaccuracies. To remove the bubble, open the stopcock, firmly grasp the burette with both hands, and give it a bit of a downward 2-handed jerk. Then check to see if the bubble is gone. Tip off the hanging drop and mount the burette for titration. We are ready to titrate. Our samples are ready. Our burette is ready. We use a homemade meniscus reader to obtain the initial burette reading. Note the eye level. Always look directly at the meniscus. Using a consistent burette reading procedure is critical. This reading is 0.94 milliliters, a value which should be recorded immediately. We bring in sample flask number 1 and position the burette so its tip extends a few centimeters below the flask rim. The student doing this titration uses a variety of delivery techniques depending on how close she is to the endpoint. Initially, she simply allows the titrant to run full bore into the flask. She uses the rate of color disappearance to guide her rate of titrant addition. Initially, the color disappears rapidly because the base from the burette reacts with the acid in the sample, producing colorless water. As more base from the burette is added to the solution, more of the acid in the sample is consumed. With less acid available in the solution, the red color lingers in the flask for a second or two after delivery of titrant. This indicates that the student is nearing the endpoint and should slow down. She needs to deliver smaller volumes with greater caution. She begins a sequence of careful cycles. Each cycle synchronizes the adding of small increments, swirling the flask, and observing color changes. As she approaches the endpoint, she decreases the titrant addition to a few drops. Watch the solution where the drops hit. The rate of color change is important. She is getting closer. She continues with ever smaller increment addition. The longer it takes for the color to fade away, the smaller the next addition. When the student believes she is within a drop of the endpoint, she rinses the inner flask walls and the burette tip to ensure that any droplets that may have splashed up are now in the solution. Now for the final addition. The student carefully allows half a drop to form on the burette tip. She touches it to the wall of the flask and rinses it into the solution. The last half drop took the solution from clear to a pale pink that indicates an excess of base. The first instance of persistent color change is the endpoint. The solution's color should be extremely pale. A careful final reading is taken. Note that our student lines her eyes up with the titrant meniscus and reads the burette the same way she did for the initial reading. 37.27. This reading should be recorded immediately. It is wise to set each of your titration flasks aside and strive for a consistent, pale color. Any major color deviations should be noted.